Now that we are done with the first problem, having given you just a glimpse of some of the basic problems, remember, I'm a guy who deals with the basics. So this is just a basic problem that I wanted us to look at. Now let's go to another problem. Okay. Now, this is what we have. They say solve the equation solve the equation 2z squared minus 2iz minus 5 equals to 0, where z is an element of a complex number. Z is an element of a complex number. So once we have found z, we must find z as a complex number. How do we know that? How do we find z as a complex number? It must have the real root and the imaginary root, because that's what a complex number is all about. Now, how do we solve this? Now, let us try to look at this. Solution. 2z squared minus 2iz minus 5 equals to 0, where z is an element of a complex number. By looking just into this, 2z squared minus 2iz minus 5 equals to 0, the highest coefficient, the highest exponent of z is 2, here it's 1, and here we have a constant. This looks exactly like a quadratic. This looks so much similar to a quadratic. Very much identical to a quadratic. So what I can do in here is to use a quadratic formula for this. So the quadratic that I will use, I will say, okay, my z will be equals to, now remember what a quadratic says. It says minus b plus or minus b squared minus 4ac divided by 2a. But I'm going to rewrite this in a sense that it maps exactly there. So the question is, this would be your a, remember, your b, and your c. Now remember, we are solving for z here. We are solving for z. And so meaning my value of b, that will be minus 2i. So this will be negative times negative. That will give you a positive 2i plus or minus 2i squared minus 4 into a into c divided by 2 into a. Remember, we are solving for z. Something worthy of noting. The formula says minus b, and your b, that should be negative times negative, that should give you a positive. You have this negative, your b, it's negative 2, hence we are saying negative times a negative should give you a positive, because we have 2z squared minus 2iz minus 5 equals to 0, and by quadratic, that is exactly what we will have. Something worthy of noting. Now when I'm here, I can just say 2i plus or minus. Remember what you will get here, you will get 4i squared. 4i squared. Negative times negative is a positive. 4 times 5 is 20. 20 times 2 is 40. Divided by 4. And 2i plus or minus. I know that I squared will be replaced with negative 1. So you will have negative 4 plus 40. Negative 4 plus 40, it's 36. Yes, because from 40, if I minus 4, I think I'll get 36. All be divided by 4. Okay, I'm going to use two ways here in case somebody doesn't want to use a quadratic. And I know that the square root of 36 is 6. I think so. So with the first one, you will say 2i plus 30 plus 6 over 4, or you will say 2I minus 6 over 4. I think these are the possibilities that you can have. Okay, so we can say, alright, I have 2I plus or minus. Let's take the positive one as 6, and let's take the other one as negative. Right, and then from there we can try and simplify this. We can say 2I over 4 plus 6 over 4, 2I over 4 minus 6 over 4. This is 1/2 I plus 3 over 2, or 1/2 I minus 3 over 2. And what is this? This would be the values of z. So maybe this will be z1 and this will be z2. And you find those values of 1/2 I plus 3.5, or minus 1/2 I minus 3 over 2 as your values of z there, because they said that z should be a complex number. Or we can just leave it even here. We can just leave it there. We can just say, okay, 2I plus or minus the square root of 36 is 6 all over 4 as the value of z. And what is this? This is a complex number. You can just leave it there if you want, and nobody is going to do you anything. Because in here, you can take out a common factor of 2 and have your I plus or minus 3. Are we fine? All over 2. Yes, 2 times I, it's 2I, and then 2 times 3, it's 6. Yes, there's a common factor of 2 there, and this is what you will find. And this should give you, sorry, this is 4, I'm very sorry. So 2 cancels 2, you are left with 2. You will have I plus or minus 3 over 4. Sorry, 2. If you cancel 2 there and you cancel 2 here, you will be left with 2 here. Yes, this is what you will have. So this is the same as 1/2 I plus or minus 3.5. Yes, so you'll have 1/2 I plus 3.5, or 1/2 I minus 3.5 as the value of your z. And it's true that z is an element of a complex number, and this is quite complex. So we are more than fine with that. We are more than fine with that. The second problem, they say find the value of x and the value of y in the following. So somebody here might have done the following. You are given 2z squared minus 2iz minus 5 equals to 0. And z should be an element of a complex number. Now, we can factorize this. I know I can rewrite this as follows. You take this 2 and you multiply that 2 with c. So you will rewrite this as z squared minus 2iz minus 2 times 5 is 10 equals to 0. And when you are here, can you find the factors of 10 that can give you 2? No, you can't. Because the factors of 10 is only 10 and 1 and 5 and 2. And 5 minus 2 will give you 3, not 2. So that becomes highly problematic. So we can't use that method. We truly can't. I can't find the factors of 10 that can give me 2. So that becomes highly problematic. So that leaves you with you have to go to a quadratic whether you like it or not. Right. Now the second problem says find the values of x and the value of y in the following equation, given that x must be an element of a real number and y should be an element of a real number. We are given that x plus y into 2 plus I equals 3 minus I. Remember the question says find the values of x and y in which x is an element of a real number and y is an element of a real number. So when we find those values of x and y, they must be real numbers. Real numbers, they can be rational, irrational, integers, whatever, as long as they are whole numbers. Now the question is, how do we go about doing that? That should be the very first question that we ask ourselves. Right, I know I was taught that whenever I see the brackets, the first thing that needs to be done is to remove the brackets by multiplication. So I'll have 2x plus xi plus 2y minus yi equals 3 minus I. This is exactly what I have. And by just looking at that, the question is, how do we go about solving that? That should be the very first thing that we should think about. Now, when I look into that, I can try to see something here. There is a pattern that emerges from this. If I group this and I take out I as a common factor, I'm still going to have 2 plus I, so it's not going to solve anything. But if I group this with this and this with that, so meaning I can group I with the i's and I can group whatever that is left with whatever that is left. So I can say 2x plus 2y, and I can say xi plus yi equals 3 minus I. And I can take out a common factor here of 2, so I can say 2 into x plus y. I can take out the common factor of I in here, plus. I'm sorry, there's a plus there. I'm very sorry. I forgot to write a plus because this is this, plus this is that. So there's a plus there. I'm very sorry. So here I can take out I and be left with x plus y. What am I doing here? I'm trying to create two brackets that are identical. And this is 3 minus I. This is exactly what I'm trying to do there. And then there's a common factor here of x plus y. I'm left with 2 plus I, that is equals to 3 minus I. So what can I do from here? What is it that I can do from here? I can, do you think we should divide by x plus y? Or what do you think that we can do there? What do you think that we can do from there? So what I can do, because I will say, I can say, okay, so when I am here, and this is what I have, look what is happening here. I can say, okay, let me not write this. Remember, this is my I. So this will represent the imaginary root, and this will represent the real root. That's one thing that I can say. I can say that. I can honestly say that. I can say, okay, this one represents the real root and the other one represents the imaginary root. So let me take this as the real root, and let me take this as the imaginary root. But the question is, how am I going to write that? Now I'm going to say, okay, 2x plus 2y is equals to 3. This is the real root on the right side. And x plus y equals the imaginary root, which is minus I. Because there's an I there, so this is the imaginary root that is equals to minus I. This is the real root, it doesn't contain I, it's equals to the real root on the right side. And I will be left with this. I have my 2x plus 2y equals 3. And I have my x plus y equals negative I. And now how do I solve for that? That should be the question. How do I solve for that? And I know the value here, it's negative I, which is negative 1. There's a negative 1 there. So instead of saying negative I, let's say negative 1. Because remember, I'm trying to find the values of x and y as real numbers. So what is this? This looks like a simultaneous equation. So I can say this is equation 1 and this is equation 2. And I can say from equation 1, I can say that x equals minus 1 minus y as my equation 3. And I can substitute 3 in 2. So 2 says 2x plus 2y equals 3. Where I see x, I'm writing minus 1 minus y. I could have used the Kramer's rule for this, but that's fine. 2 into minus 1 minus y plus 2y equals 3. This will be minus 2y plus 2y equals 3. Now we have a problem here. We have a serious problem here. This and this are going to cancel out. So something is wrong. Something is highly and highly wrong. Something is wrong here. Something is highly and highly wrong. It should have never and ever been like this. It should have never and ever been like this. Now, let us look whether I multiplied correctly here. Let me check. X plus y was the problem. Oh, sorry, wonderful people. I am so sorry. I think I'm the one who made a mistake. There should have been an I here. I am highly and highly sorry for this. There's an I here. Jesus. I can see that something is not adding up. I am so sorry, guys. There is an I here. I am sorry. I am so sorry, guys. Please forgive me. There is an I there. There is an I. I can see that when we are trying to solve y cancels with y, this makes no sense at all. So I'm very sorry for that. Please, this is 2x plus xi plus 2yi plus yi squared equals 3 minus I. I'm very sorry. And somebody might be asking himself Ndabezita, why are you not taking this to the other side? Why are you not doing that? I know that the left hand side is equals to the right hand side here. And the question says find the values of x and y where x and y are real numbers. So taking this to the other side is going to create a very serious problems. Why? But we will see. Let's just try to work on this and see what transpires from this. So I will have my 2x plus xi plus 2yi plus y. Where I see I squared, I write negative 1, 3 minus I. Let me deal with the left hand side first. 2x plus xi plus 2yi negative y, very important, equals 3 minus I. Can you see that even if you can take this to the side, there's no way you are going to simplify that? Can you see this? It's going to force you to take it back again to the other side because there's no common factor, there's no like term where you can add or even subtract 3 or minus I. That's why I will not even bother myself taking this to the side. Right. And now when I'm here, I'm going to try and group the real root with the imaginary root. Whatever that is real does not contain I. Whatever that is imaginary contains I. So this and this would be real because it contains no I. So yes, so I will say 2x minus y, grouping this with this, plus xi plus 2yi equals 3 minus I. So this should be, do you think that it should be grouped like this? No, it can't because there's no common factor here. There is a common factor there, but I can't do that. There's a 2 here, there's a 2 there. The aim is to create 2 brackets that are the same. That's exactly what I would like to do here if it is possible. So how about I group 2x with 2yi and I group xi with minus y. This is equals to 3 minus I. If I write it like this, am I going to get anywhere? Let me try and check. I can factor out 2. I'll have x plus yi, okay, and then in here I can say, okay, I have minus y plus xi. And if I factor out a negative there, plus factor out a negative, I will have y minus xi equals 3 minus I. Negative times positive is a negative. Now, is this going to help me with anything? That is my question. Is that going to help me with anything? I don't think so. This is never and ever going to help me with anything. So what I could have done when I was here, let me get rid of this. What I could have done was to say, okay, I have my 2x minus y, there's no common factor. There's a common factor of I here, let me take it out. I'll have x plus 2y equals 3 minus I. Can you see what is happening now? Now, if this is what I have, now what should be the second procedural method? What should be the second step into this? So, let me just group this. I have this. I will treat this as the real part and I will treat this as the imaginary part. I think this makes sense. You don't have I, you are the real part. You have I, you are the imaginary part. You are making sense that this is the real root and you are making sense that this should be the imaginary root. So it will be correct mathematically to say 2x minus y. For those who studied electrical engineering will understand this, and many others, of course, from grade 9. 2x minus y will be equals to 3, because this is the real part on the left equals the real part on the right. And I will have the second equation where I say x plus 2y equals the imaginary part, but I'm not going to write I there. I'm going to write the coefficient of I, which is negative 1. And now I can say this is equation 1 and this is equation 2. And I can say from equation 1, I can say that minus y equals 3 minus 2x and y equals 2x minus 3 being my equation 3. I can say that, and I'm very sorry for the lengthy tutorial because of the mistake that I have done. And then I can say I'm going to substitute 3 in 2. And where I see y in this, I'm going to write 2x minus 3, that is equals to 3. Remember, I'm substituting there. And I can have x plus 4x minus 6 equals 3. This is 5x equals, take to the other side, and that should be 9. 5x equals 9, and I'll find my x as 9 over 5. That's exactly what you will find there. Okay. I don't know if this is making sense. We have x plus 4x minus 6, which is equals to, negative 1. Jesus. We are substituting here. X plus 2y, it's not equals to 3. I'm very sorry, this is equals to negative 1. I am very, very sorry. So you will have minus 1 plus 6, that will give you 5, and you will find your x as 1. I'm sorry for that mistake. Your x is equals to 1, and I can say this is my equation 4, and I will substitute 4 in 3. Y equals 2 into 1 minus 3, 2 minus 3, negative 1. So x equals 1 and y equals negative 1.